Hello.
Hello, am I audible?
Hello.
Hello, sir. Am I audible? Hello, sir. Am I audible? Renzi, sir, please.
Teacher, you are audible.
Hello.
Srinivas sir, can you hear? Srinivas sir, can you hear us?
Hello. Can you hear me?
Yes, we can hear you.
Okay. Just want to check whether it's possible. Audible. Okay. Thank you.
Renzi, sir, shall we start the program?
Yes, ma'am.
Over to Sri Lakshmi.
Yes, ma'am. Good morning to one and all. A very warm welcome to each one of you. Today, we have gathered here for the inauguration of FTP on LoRaWAN and IoT applications. LoRaWAN is a low-power wide area networking protocol designed to wirelessly connect battery-operated things to the internet in regional, national, or global networks. Today's session is sponsored by APJ Abdul Kalam Technological University in collaboration with ICFOSS Trivandrum. As we know, ICFOSS is an autonomous organization set up by the government of Kerala in 2008. Today, they carry out a number of force-related activities in a model that brings together academia, industry, government, and force community. Before we begin, I would like to invite Veena Surendran for the prayer.
നന്മയാകുന്ന കാന്തി കാണുവാൻ കണ്ണിനാകേണമേ നല്ല വാക്കിൻ്റെ ശീലു ചൊല്ലുവാൻ നാവിനാകേണമേ സ്നേഹമാകുന്ന ഗീതമോയിൻ്റെ കാതിലിണയാകണേ സത്യമെന്നുള്ള ശീലമോടെ ഞാൻ ശാന്തിയറിയണമേ ആ ഭൂമിയമ്മയെന്നറിയുവാനുള്ള ബോധമുണ്ടാകണേ ജീവജാലങ്ങളാകെയും ജന്മബന്ധുവായിടണേ ജാതിഭേദങ്ങളെന്ന ശാപം ലോകമൊന്നിന്ന പാഠമെന്നുമേ മനസ്സിലെഴുതേണമേ ആ ആ
Thank you, Veena. Now, I would like to invite our FTP coordinator, Dr. Mary Reena, for welcome speech.
Good morning, all. I wish all of you a happy and healthy stay at your workplaces or home. Here we start our FTP on LoRaWAN and IoT application. So this is a recent technology and it has a good future also. You can find many applications. So this is a new kind of FDP uh, that is mostly based on the lab sessions, and I think it would be a new experience to all participants. Happy learning to all, and I want to do my duties entrusted upon me. I welcome Dr. Mohammad Shukur, our beloved principal, who is our constant source of inspiration and always supporting with all programs being conducted by AC department. So I a warm welcome, sir. Next, next I welcome our chief guest, Srinivas sir, and he is going to deliver the first session today. He's the program head of IC Force. So already we have an MOU signed with IC Force for a LoRa Inbox project. And this is another collaboration with IC Force. I thank all Srinivas sir and all the IC Force team for this support and a very warm welcome to Srinivas sir to this program on behalf of our college, our department, and entire participants.
Thank you.
Warm welcome, sir. Then I welcome all the deans and HODs and our colleagues and all the participants and student friends and our HOD Shiba ma'am. A special welcome note to our HOD, and our HOD is always giving a constant support to us and encouraging us for arranging all the programs. As well as my coordinator NC sir also, and all my colleagues in my department and colleagues, and all the participants, all the beloved participants, I extend a warm welcome. And that's all. We think this is a new a learning. We've kind first of a week experience this time. So a happy learning ahead. Thank you all.
Thank you, ma'am. Now, for the presidential address, I would like to invite our Honorable Principal, Dr. Muhammad Shakurti.
Morning to you all. Can you hear me? Very Dina? കേൾക്കുന്നുണ്ടോ?
Yes, sir.
കേൾക്കുന്നുണ്ട്
हाँ sir,
കേൾക്കുന്നുണ്ട്.
Good morning.
sir. Audible.
So respected another department, Dr. Shiba madam, our guest Srinivas R, other deans, other departments, colleagues, new student friends, they're there. All of you, good morning. It is, as I always say, one thing we have learned during this time is how to share our experience online. All common people are now customized with this online sharing of experiences. And I see a lot of things happening in our college. All the departments are racing for otherwise we used to have one or two FTPs per year. Now monthly one or two FTPs we have in the college now. And one more thing I see is the applications received by universities or ACTs are scrutinized well now to select appropriate and trending current technologies as the topic of all these FTPs. And again, they are monitoring well for the proper conduct of this FTPs. So One more thing I feel happy is last 6 months, I think, I've come more to electronics department for any such program. So I congratulate electronics departments for having more and more such programs. Then here we have Sri Srinivasan R with the program head of IC First, and we have IC First associated with us in many different programs here. We had I had to Renzi Sam Matthew, I knew about IC First. Well, he is coordinating a IC First program, and MO is signed with IC First. So I'm happy to have Mr. Srinivasan R with us for sharing our experiences with the Srinivasan R. And I thank him and appreciate him for associating with us in all these programs. So one thing I expect is very good participation, not only very good participation, very sincere participation from all the participants for maximum use of all these programs. I wish all the best for the electronics department and this FTP. Thank you.
Thank you, sir. Today with us, we have Mr. Srinivasan sir, who's currently working in International Center for Free and Open Source Software for the last 9 years. Formerly, he was the Director of Technology in Britec India Pvt Limited, Director of Technology and CEO of OneView Systems Private Limited, and Director of Technology of Cell Technologies India Pvt Limited. He was the former chairman of IEEE Kerala section and IEEE. Hello, sir.
Hello, can you hear me now?
Yeah, we can hear you now.
Hello. Okay. Good morning to all. It gives me great pleasure representing ICFOS for this faculty development program in IoT and LoRaWAN. I had visited LBS Institute at Kasaragod long time back as part of my volunteering efforts as IEEE leader positions. That's quite a long time back. And thereafter, the interaction came when IC4s went ahead with the LoRaWAN deployment across Kerala. We invited proposals from engineering colleges across Kerala, and quite interesting that LBS Kasaragod was the identified partner for Kasaragod district. We had established something like one in each district. At that time, we were limited with the resources to go for more implementations. So we had to restrict ourselves with one per district, and LBS was the identified partner. Now, the identification of the partner was quite a big, tough task for ICFOS. Because in our mind, we wanted to give the facility to each and every engineering college in state. Because of resource restrictions, we had to identify one per district, and we went through certain evaluation criteria on the number of projects which the faculty members of the institutions conducted and things like that, number of papers published, and so many detailed criteria was worked out. And LBS easily qualified for Kasaragod district. Right from my first interaction with Kasaragod LBS, I have been seeing a vibrant type of campus with a lot of work, a lot of passion happening. Probably there were some limitations in the past, but from the history of the institute, I understand that it is catering to some of the good requirements of the district and state, and a lot of professionals are coming out of from college and working in different organizations. Talking about the relevance of the current topic for FDP, the Internet of Things, blockchain, and so many other technologies are coming into the forefront, data analytics. Those are the topics which are being considered hot during these pandemic periods also, because we are talking about data being collected from different resources, and then how do we transmit those data for processing across different communication systems, and computing on that and taking appropriate actions. So internet happens to be the backbone of everything right now, or basically it is a connected world. And even though we started using internet some few years back, the requirement is gathering over a period. Now, earlier we used to have internet connected computers. Then we came across internet connected tablets or some other devices similar to computers. Then phones, internet connected phones, and we almost every citizen now has one or two phones connected to the internet. And now we are seeing devices connected, or even different living animals themselves connected through different processes to the internet. And each of this is transmitting data, knowingly or unknowingly. That is one of the big things being discussed, whether we are transmitting unknowingly some amount of data. So all these are taken care of by the biggest cooperative network in the world, which is called Internet. And there are a number of bodies, professional, volunteering, and other organizations which work behind this Internet and take out every such organization. I used to volunteer for something like Internet Society, and I was lucky to participate in some of the ICANN discussions and things like that. If you look around, every such internet-related organizations are now discussing about how we can accommodate these billions of connected devices. And second thing is how we can effectively handle the zettabytes of data which is coming up. So all these are some of the things which we take up in IC4s also. Even though IC4s is oriented with promotion of free and open source solutions, we indulge ourselves in different type of domain requirements. For example, computing, language computing, the open hardware, and something like assistive technology and things like that, and promote the use of free and open source among all these topics, all these domains. Effectively, IoT is one of the core topics which we handle within our open hardware lab. And one of the primary things which we focus on is about how we can make use of IoT for sustainable development of the society. Probably during my presentation, which comes on later on, I would like to share the experience of how we have been doing all this in ICFOS and what the technology is all about. And so basically, IoT stands as the best tool looking forward for the society as a tool for enabling sustainable development. As you all are aware, UN has come out with the sustainable development goals, which we are expected to meet at a certain point of time. Every country is expected to meet at a certain point of time. And luckily, our state, Kerala, is one of the lead runners in meeting those goals. But employing those tools is something which we have to work upon. We at ICFOS are now looking forward to interact more with the academic community through these type of associations and share our experience, share our goals with the academic community so that we can work together to bring some of the best solutions for our local market. We all have been working in different silos in the past, I must admit that. We have been doing something, academic people are doing something, industry have been doing something, all for the benefit of the respective groups. But now the time has come up where we need to work on this, especially the pandemic, which came across right now, have taught us many lessons, including that internet is the real backbone which can help us survive. That is one of the lessons the pandemic has taught us. And please think about the pandemic days without internet, without telecom, and the world would have been totally in a chaos without those things. So pandemic has given us some lessons. So we need to collaborate. We need to work on projects which are suitable for our society in even our normal landscape. So all these things have to be taken up. So one of the agenda which we wanted to take over was the capacity building on technologies which we were working, which we have certainly established proof of concept and even gone one step more, like implementing across in some parts of the world or in our state itself, with the academic community involvement, so that we have more people available for the industry as well as the organizations which require such capacity. And it is obvious that IoT professionals are required. If you look around the job scenario itself, I consistently watch the LinkedIn job scenario and other job scenario on IoT specifically, and I can see that it is quite large numbers are coming up. And for the agenda of this capacity building in IoT, we need to have one ecosystem which is easily accessible, and that is why LoRaWAN has been considered. More of that at some point of time. So it is a time when we all have to work together, collaborate together in implementing sustainable solutions using the appropriate and best of the technologies. And I wish the team of LBS and all the members who have joined here or either attending these sessions at a point of time to be part of this collaboration and work towards attaining our goals at different levels. And with the due permission from the organizers, the participants, and all those who are behind this, and I have a beautiful team with me at ICFOS who have worked on this in spite of their busy schedules with different goals, meeting either met or being lagged, and working on all those things in spite of the pandemic. And something like the virtual lab, which is going to be used for these sessions. So with all the permission, I declare this FDP open and inaugurate this with all the blessings from all of you. Thank you very much.
Thank you so much, sir. Next, I cordially invite Dr. Vinod George, Dean of Student Affairs, for the felicitation.
Respected Principal Dr. Muhammad Shukur sir, and today's chief guest, ICFO's Program Officer, Program Head, Mr. Srinivasan, and all dear colleagues, coordinators of this program, dear participants, a very warm good morning to all. First of all, I take this opportunity to congratulate the coordinators and the department for organizing a FDP on such a hot topic. LoRaWAN and IoT application. This is one among the most hot topic in current technological scenario. So it has got this particular area or particular topic has got a wide range of application. As our chief guest told, it has got applications in all our day-to-day life activities. So once again, I congratulate all the both the coordinators and the department for conducting such an FTP. Nowadays, many FDPs are going on in online platform, especially after this pandemic. We are also conducting many faculty development program or other training programs in the online platform. But whenever we are thinking about the effectiveness or the utility, I think the utility or the effectiveness was slightly lower than the offline programs. Means here we have got very a lot of areas or lot of opportunities for attending the program. Being a participant, it is our responsibility to utilize such an opportunity. So I wish all success for this training program and also a happy learning for all the participants. Thank you. Thank you all.
Thank you, sir. Now, to felicitate the gathering, I'd like to invite HOD of ECE Department, Dr. Shibake.
Okay, thank you. Very warm good morning to one and all present here. First of all, on behalf of the Electronics and Communication Engineering Department, I welcome all of you to this inaugural function. That is the 3 days inaugural program, 3 days program. And respected Principal, Dr. Muhammad Shukur sir, respected Chief Guest of this program, ICFO's Program Head, Mr. Srinivasan sir, then respected Deans, then respected HODs of various departments, my dear participants, dear colleagues, and my dear students. Actually, I want to say something. Something now about this ICFOS. Actually, ICFOS is an international center for popularizing free and open softwares. That is in my opinion, that is the use of open software is very much needed, especially in our educational institutions. So we have to promote that use of open softwares in our institutions also. And also, ICFOS promote the study and researches in IoT application. As Vinod sir said, this is a very hot area, IoT applications. That is the topic of our FTP. So I would like to appreciate our coordinators Dr. Marina Kay, and Professor Rencisa Matthew for arranging the appropriate person as our chief guest who can give proper and relevant guidance or advice to us in our future work in the domain of IoT applications using the open wireless standard LoRaWAN. Actually, we have a limited knowledge about the LoRaWAN. So how to use it, how can we use in the different applications like agriculture, industry, even you can use in the colleges, etc. So you will get a very good idea and okay, some idea after this FTP program. Hence, coordinators have arranged good sessions, very informative sessions in this FTP. And also, I take this opportunity to appreciate the coordinators and the EC team for the work, sincere work, for the successfully organizing this program. Actually, LoRaWAN and IoT application is a socially relevant topic. As I said, it's a very socially relevant topic. You can use in different applications. The domain of IoT, we know what is IoT, Internet of Things. Actually, it is revolutionized by LoRaWAN standard by enabling data communication over long distance at a low power. That is the importance of LoRaWAN. You can transmit the data for a long distance in a different application at a low power. Ensure that all sessions in the FTP is very informative, including the virtual lab facility at IC4s. I'm not extending, and my sincere or eagerly, I know that you are all eagerly waiting for sir's very informative sessions. So thank you all. Stay safe and happy learning. Thank you, sir. And also I would like to say that, sir, we are very happy that we are recognized or we are recognized as one of the institutions by IC4s. So thank you, sir, for giving us this opportunity. Thank you, Srinivasa. Thank you all.
Thank you, ma'am. Now, I cordially invite Professor Rencisa Matthew, FTP Coordinator, for vote of
Good morning, everyone. I'm indeed privileged to propose the vote of thanks for this inauguration session. We have carefully planned this FDP in partnering with IC4s and handled by eminent people from the industry and from IC4s. So, and the highlight of this FDP would be the hands-on training using the facility in IC4s. So, Trivandrum, we will be all doing the programming through the facility in IC4s Trivandrum. So that would be a highlight to the program. So don't miss the hands-on sessions also. At the onset, I want to thank Almighty's showers of blessing on keeping all of us safe and helping us to interconnect through this online platform. I'm very grateful to our principal, Dr. Muhammad Shikuti, for presiding over this inauguration session and delivering the presidential address. I want to thank Srinivasa, program head of IC4s, as well as the entire IC4s team for all the help done so far, and especially thanks to Srinivasa for inaugurating this program. I want to thank our Dean, Dr. Vinod Ujjwal sir, all the HODs present, especially HOD of EC department, Dr. Shiba K, for all the help and support given to us. I want to thank all the participants for joining in this FTP. I'm thankful to all my colleagues and my students who also have joined this program. So let it be a time of learning and wishing you all the best. Thank you.
Thank you, sir. With this, we come to an end of the inaugural ceremony. Now I heartfully invite Mr. Srinivas sir to take up the session.
Thank you very much. Give me a minute for loading the presentation.
Sure, sir.
Hope you can hear me. Hello, are you able to see the screen now?
Yes, sir. Yes.
Yes, sir.
Okay. Thank you. Okay, can I start? Hello?
Yes, sir.
Shall I start? Okay.
Yes, sir.
All right. Thank you very much. A warm good morning to all of you again. Now I slip into the shoes of a presenter or a speaker for the session. And I thank the organizers, APJ KTU, the Technological University, the mainstay of our technological activities in our state, for allowing such a program, and LBS College, Kasagod, Engineering College, Kasagod, for applying for the same and collaborating with ICFOS for such a session. As I mentioned earlier, we have been looking for opportunities for capacity building in Internet of Things, or very precisely, Open Internet of Things, being an organization which is focused on open source software and hardware. Okay, stepping into the topic, Internet of Things. It is shaping the way we live our lives now. That is what we call the current state of Internet of Things. Years back, when I started programming way back in something around 87 and those times, 87 to 90s and all, we were not thinking about even much of connectivity at those point of time. 90s above. One second, please. ഞാനിവിടെ FDPയുടെ സെഷൻ ഇവിടെ നിന്ന് ചെയ്തിട്ട് അങ്ങോട്ട് വരുള്ളൂ കേട്ടോ. എന്തെങ്കിലും ആവശ്യം ഉണ്ടെങ്കിൽ എന്നെ വിളിച്ചാൽ മതി. മറ്റേ കാസർഗോഡ്. ശരി, ഓക്കെ, താങ്ക് യു. Sorry about that. So we were not thinking much about connectivity itself. Like, we had computers which were connected to a certain extent. And then came the concepts of email and things like that, messaging to some extent. Then started internet as such. And today, I don't think many of us can survive without internet. I'm not sure how many of you have actually tried that. I usually try once in a year to keep away from all the connectivity. And over a period of time, it is becoming very tough to survive more than one day. So that much we are used to this internet. Earlier, it was only internet of connected computers. Now we are talking about internet of things, internet of everything, or whatever you call, it's become a connected world. And the wording there given, it's quite simple, and it is the way we are. That is, it is shaping the way we live our lives. Your TV is connected, your watch is connected, your refrigerator is connected, your pet is connected, your car is connected, you yourself are connected. To what? To the internet, one way or other. And then that helps her. Like, because even in this case of the pandemic right now, we have been using a lot of connected solutions, knowingly or unknowingly. To take the vaccine management across, the logistics, a lot of things have been working. So it's really shaping the way we live our lives. So in this presentation, which I expect to complete within 1.5 hours or so, I will touch upon the general Internet of Things, the trends and things like that, because most of you are now heard the term or at least working on this or using this as the consumer of Internet of Things. And especially now, why LPWAN, low power wide area networks, and LPWAN types, the challenges, trends, opportunities, and then something about the lab where my team works at ICFOS, and some concluding remarks where I will be open to questions at that stage. So anything that can be connected will be connected is another term which we take up for Internet of Things. And basically it is network of things. Network, as we know, like it enables connection. And now we are talking about smart objects. Now, weren't these objects smarter earlier? They were smarter earlier, like any of these objects which are talking about. For example, your fridge was smart. Your car was smart. Or any of the devices you're talking, the humans were smart, or any of the things. But when the smartness and the utility has to increase, it has to depend upon information from across or around it or nearby, or some intelligence which was lacking in those smart objects could be enhanced because of intelligence made available from other sources. So that is where the network comes in. So when we talk about network, we generally what we used to understand in the older days was about these what do you call it? LAN connections or PSTN connections. Those were networks, right? We had PSTN connections. Those were networks. Cabled connections. Even now we have got a lot of LAN connections or cabled connections, which take care of a lot of things, including our TVs or even our telephone networks, phones, and things like that. Even our internet connection to a large extent based on cabled connections. Then came the concept of wireless networks, short-range wireless networks, long-range wireless networks. And why these networks came into prominence? Because you cannot expect to wire all the way up to hundreds of meters every time, like because most of our cables run. The fiber cables run kilometers, but last mile connectivity and other things, we need to work on wireless connectivity. Even now, when you have laptops, you prefer to have a wireless connectivity rather than, even if you can opt for a LAN or cabled connectivity. So with these two networks, now when the networks are connected to objects, it enhances the intelligence capability, potential of those objects. And that is where we see that the real world is going to be connected with the virtual world. And that is where we have the Internet of Things coming up. So the possibility is that you are going to have billions of connected devices. It is not millions or something, it is billions of connected devices. You take your own case, you now have at least 4 to 5 connected devices. You talk about starting with your computer, your laptop, your watch, your goggles, your light at your home, everything possible, possibly connected. Your water meter, your electric meter, everything. Slowly it is pitching up in every case of it, like where you are getting it connected. So that's about Internet of Things. Please understand the term, it is connection between the real world and the virtual world. So probably the evolution of all this Internet of Things, we had small devices or the PLCs and things like that. Then you're talking about farm boards, open PLC, open gardens, e-health, something like cooking hacks. Hacks like this have been helping in the evolution of IoT. All about the Internet of Things history and all, it was mentioned like something around 1976 also. Onwards, you had IoT as a term coined up. But then the prominence came when after the Internet itself came into existence. Sorry, 96. Now we are talking about the smart citizen, like, so from very specific devices which are meant to be connected with all the ports for connectivity, if you look into the Pi and things like that, to the smart citizen, where you are talking about gadgets all across you. The evolution has been different. I will come across many such use cases. So some of the typical use cases, going by categories, one of the smart factories, where the asset management is going to be critical. When you say factories, earlier we used to talk about big factories like the Tatas and things like that. But now you can say that even the smaller enterprises, wherever there is amount of manufacturing, you have the requirement of IoT, probably coined under the term industrial IoT. So one particular area where this is being used is the asset management. They have, because every factory you talk about certain raw materials being produced, being processed into the final product. And so you have a lot of assets there, including the raw materials, including the manufacturing machinery, including the transportation machinery and things like that. So that asset management can be easily handled by these type of intelligent things associated with this. Another thing is about the predictive maintenance. When we talk about factories, you're talking about a lot of machinery. These lot of machinery, gone are the days when you can afford a downtime of these machineries for hours together. We talk about machineries continuously running, or with very predicted type of downtime, planned well that it doesn't affect the productivity. So those type of maintenance activities, you're talking about collecting data related to the performance of these machineries. And how do we collect the data? While the machinery is working on, you need to sense some of the information which are critical for the maintenance. Pass the data to processing capability machines, and then they take about predictive. So they can predict like, okay, 5 days from now, we may require a maintenance of that particular machine. So you are getting planned for that instead of getting it all by a surprise. So you have got industrial process automation and optimization. Any process automation which you talk about, you have data to be collected, data to be sensed, and that to be made use of. So in general, industrial process automation or optimization talks about connected things. Energy management is another category of smart factories where IoT is being talked about. Energy management is very critical for factories, especially smart factories, where you constantly monitor the energy utilization and make corrections if required. Switching off certain systems which are not to be powered at that point of time. All those things, energy management, again calls for data acquisition and working on that. And this data acquisition, don't think that every time you can manage with cables and all things coming across. Some of these have to be in the wireless area itself, depending upon the typical scenario. Talking about smart cities, I think even every in Kerala itself, smart city has got two types of conditions. One talking about the real smart city enabling of some of our cities, and then another one where you're talking about industrial area called smart cities. But I'm talking about the average citizens improvement with smart cities. Where smart lighting is one of the biggest use case for smart cities. There are most of the companies which come out with LED and other lighting systems. They are now coming with a lot of lighting control solutions. It is not just switching on the light alone, like it is switching on the light intensity, switching on the light at certain points of time, depending upon the environment, and all those factors comes into lighting, but smart lighting. For that, you need to collect data about the environment itself at some point of time. So smart lighting, smart parking is one, because in the smart cities, you are supposed to have all the comfort at a very optimized level. And parking, even one of our incubator companies in IC4s, companies incubated in IC4s, is working on smart parking. And they have implemented a LoRaWAN based smart parking solution inside Technopark, making use of some of our gateways and things like that. And they are extending it to other industries. Even in Kerala, I must say that they are getting orders now. Think about other opportunities. They even got good opportunities from Calcutta and other places. In outside India, there are a lot of opportunities on smart parking, organized parking and inorganized parking. That's it. Think about all the parkings required along with the railway stations or the metro stations. They are all going to be smart parking solutions. Noise monitoring. As we all know, smart cities, we are talking about very, what you call, amicable type of very smart environment itself, where monitoring of the noise is very critical. So, so we have, like, if you look around the smart use cases, we have noise monitoring, because noise is something which is affecting our health. And so the monitoring of that is one of the use cases which is happening. Structural health monitoring. All the smart cities, we are talking about multi-level bridges and all those things, and even industrial requirements, not industrial requirements like huge apartments, huge villas and things like that, all connected using better traffic infrastructure. And each of this infrastructure requires monitoring, like the bridges getting monitored, the structural stability, because most of the structures are now being built with high amount of sophistication. And so there is a requirement for monitoring of that on a continuous nature. And you need to collect data, sensors like the pressure sensors and all those things. Level sensors have to be installed and that need to be monitored. Waste management, obviously, that is one of the solutions which we see many of the solutions, and I'm very interested to see that number of student projects are being considered in this. Unfortunately, none goes beyond the student projects, probably because of the waste itself. But this is a big sector which is being worked upon in the smart cities, because all these topics which are covered under smart cities are aimed at a smarter life for the citizen. You have many more, but I'm taking only this one. Water management is one of the key areas. If you look around all the IoT companies like Labelium and all those companies, water management is a big area which is being considered. Water conservation involves the amount of water which comes in, which gets stored, and all those things. Even we had an opportunity to work on water conservation and things with one of the nearby legislative area. Thanks to one of the very prominent MLAs of Kerala, the Katakada area, we were asked to work with them on getting the amount of water and how much of water gets stored into that area. So we had rain gauges and everything built in. I will come to that use cases later on. So this is important. Now, fortunately or unfortunately, we are a water positive type of state. And so we don't give much value to this at present, but we are seeing signals about all these requirements as we move on. So water conservation, then smart irrigation. Smart irrigation is again connected to the water conservation. Smart irrigation means like the irrigation is done such a way that we don't waste much of our resources into producing the agriculture products. Even if it's a fertilizer, even if it is water, even if it's other environmental parameters. And at the same time, we also need to put factors or put something like environment which gives you more productivity on the irrigation. So all these talks about sensing something and then taking action on that. Leakage management, again, this is something which Kerala doesn't understand. Why? Because we have surplus water at some or other point. Whereas many other places, you take states across the border, leakage is big thing. Think about, even we had some simple calculations like 1 drop per tap at 1 second, and what is the amount of leakage which is coming in. So we need to have leakage management as part of the water management, not only in the residential lines, but also in major lines. Like think about, you must be witnessing a lot of leakages happening even here, there, etc. Added together, that actually contributes to a big leakage from our own money generation and things like that. And water quality management, this we are experiencing in Kerala right now. Most of our water resources are contaminated. So we have a lot of water resources, like we have a lot of ponds, we have a lot of other static water bodies, but we are not able to say that, okay, we can use the water stored there. So we need to have quality management, not only in tap water supplies, but other ponds and other things, wells. We are lucky to have a lot of water bodies, the groundwater and subsurface water and all those things are there. But we need to ensure water quality, which is coming up. Even there are many requirements coming up on account of this, because of the agriculture requirements and otherwise the residential requirements. Other thing is the digital health. Digital health, one typical things are about the ultraviolet radiation monitoring. In some of the what do you call rain gauges and other things, we provide this ultraviolet radiation monitoring, which is critical for the health standards. And some other things are about the fall detection and other of aged people, or any type of people who are bound to have more issues because of these falls or something like that. Things like the companion robots, where robots help you, are becoming helpers, and medical fridges. This is something. There are typical requirements of monitoring, even in the case of vaccines, which we are now seeing. We need to monitor the fridges for the temperature maintenance, even other condition maintenance inside the fridges. So that is something again. So if you look into these things, please understand that we are making use of simple measurements like temperature, humidity, pressure, and things like that for this. For medical fridges, what do you require? You require to measure temperatures inside the fridge. So simple sensors can help you making very efficient decisions regarding the utility. And then another one is the patient surveillance, remote patient monitoring. No need to talk about that. We are seeing it all across. How patients need to be monitored, even in hospitals or even otherwise, patients need to be monitored. We are talking about half the population going into diseases at some point of time. And you cannot expect everything to be inside the hospital under controlled environments. So we have that digital health capability. Now, smart retail, we have supply chain control. Obviously, the term is clear. We have supply happening, and then their chain has to be monitored. Where one see when you go into a retail shop and take out a item, it should be possible for you to understand where it originated, at what time it came up, and things like that. If that is the case, like then we need to collect data from each one point of its transit from the production to the retail. So smart supply chain control, near field communication payments, you are experiencing that. Some of the cards, some of the bank cards are now NFC enabled and things like that. How do you take care of all those things? Layout optimization, this is something interesting. And you might have heard about this. Even now in some of the malls or other places, when you go, you suddenly see that the layout is different. Today, when you have a rack which is with all the fruit juices there, tomorrow it is replaced by something else. Why do they want to do it? They have one reason to the blankness, change of positioning based on user requirements. So those layout optimizations can be worked out with these type of sensing devices. And smart product management, and their product management can be done like this.
Sir, I want to interrupt you, sir.
Yeah.
Sir, are you changing the slides?
Yeah, I am changing the slides actually.
So we are not able to see that.
Oh,
I am not able to see. What about others?
Are you not able to see? Can anyone else come out?
Still showing the title slide.
Sorry?
Still showing the title slide itself. The first slide.
Oh, okay. Okay, give me a second. Oh, okay. Because, are you able to see now?
Yes.
Yes, sir.
Okay. I don't think I have to go back on this.
No need, sir.
Is it okay? I continue with this? I think I have been talking based on the slides. Okay.
Yes.
I'm sorry about that. Yeah. Now about smart workplace. Smart workplace are the sociometric badges. Like when this is very relevant at present, where you are expected to. 1 second. Are you able to see the presentation now?
Yes, we can see the presentation. Yes, sir.
Okay. Just checking, shifting your slides. Are you able to see that?
Now it changed. Water management, water conservation.
Fine. So the social distancing is something which we are talking about, smart workplace. Now, government is coming out with many type of social distancing requirements. We are talking about like you need to maintain this much distance and things like that. So sociometric badges are something which are being worked for the smart workplaces. Even though it is planned earlier, this is something which is of much relevance nowadays. There are many more applications, but I'm talking about the smart workplace one. Then even there are things like in smart workplace, there could be things like your what you call helmets, which gather a lot of information. There could be wearables which will be taking a lot of information, and so on. It all concerns with the specific social parameters and then taking actions based on that. Smart homes, of course, all your homes now talk about many type of IoT applications. Right now, the smart home applications, which in Kerala we are talking about, are talking only to the respective residents. But now you are going to have more and more applications. Even now, some of your appliances are talking to outside world, like your smart TV. Your devices like the Amazon devices and things like that. So basically remote control applications. Smart logistics, we have fleet tracking. Fleet tracking is one of the big things which IoT is into. Not just the old days when you can, even your postal things are being monitored. So that type of smart logistics and connected vehicles. Connected vehicles is a big segment which you are talking about, where you can even come to know about where your vehicle, your logistic portion is happening. It's not just related to your cars alone. We are talking about ships. We are talking about airplanes. We are talking about UAVs. Everything being considered as a connected vehicle. Smart metering, any metering concept which we put into our citizen life, we are talking about smart metering. So it can be gas metering, it can be water metering, it can be electricity, power metering, energy metering. So anything which needs to be metered, you need to have a smart metering. What meant by smart metering is like essentially what exactly is consumed that had to be metered, and you have to work based on that. Some of the smart metering applications, we are actually connecting that to other aspects as well. For example, leak management with metering. That is being considered, because whenever you have metering, you know about the volume which is being flowing through the system, and so you can have certain other managements also coming into the picture. Even now we are talking about pandemic situation evaluation with the help of smart metering, because even there are indications where you all this data getting processed with your machine learning systems, you are talking about infinite number of other possibilities. These concepts right now which we are discussing are just about collecting data and doing things, but the extension of that into machine learning and other artificial intelligence and other things, you're talking about huge potential. Digital twins is something, again, for every person you can have a digital twin which can take care of a lot of things which you need not physically take care at this point of time, and more. So that is about the potential. Since people didn't miss the slides, these are the slides which we are talking about. Smart factories, smart cities. water management, digital health, smart retail, and then some of the things. There can be any more number of applications if you can, because instead of smart home, we are talking about smart villages, or smart cities. Instead of that, we are talking about smart villages. So usually smart is associated with IoT right now because basically the communication, computing, and everything involved in that is expected to make that concept smart. That's all. And what do you mean by smart is only the one thing. It gives more comfort to the average citizen, nothing more than that. In my inaugural talk and the things, I talked about sustainable development goals. I hope most of you are aware about these sustainable development goals. If you look around that screen, you can see that 17 number of sustainable development goals are promoted by UN, which is expected to help countries attain an average expected citizen comfort levels across the world. So some of the sustainable development goals are better addressed using IoT. So for example, zero hunger, that is SDG 2, SDG 3, good health and well-being, SDG 6, clean water and sanitation. Now you must be knowing how you connect between the IoT goals, IoT use cases, and some of this. Clean water and sanitation, industry, innovation and infrastructure, that is infrastructure management, something. Sustainable cities, which are otherwise called the smart cities. Climate action, that is environment monitoring and things like that. Life below water, that is rivers and other things, under sea and all those things. Life on land, obviously all the things which come up. So these are the sustainable development goals which are better addressed with IoT. And there will be opportunities for each one of you if you try to address one of these SDG goals, and then there will be a huge number of projects which you can address, and there will be a huge number of opportunities if you work with government or other organizations in some of these things, the sustainable development goals. Now talking about IoT, probably you might have seen that number of installed IoT devices around the world is going to be 75-80 billion in 2025 and things like that. Some of the current statistics is that number of connected devices in 2021 is said to be 46 billion. Obviously, and now the internet related organizations are really brainstorming on how do we take care of this 46 or 80 billions in 2025. You talk about any device connected, you need to have certain protocols working, certain data source working, and things like that. And it's quite huge. Think about this. By the end of 2021, 31 new billion IoT devices will be installed around the world. These are from different sources, just to give you information about. And it's almost working like projected. The average number of connected devices per household in the US in 2020 was 10. Now, US is one place where we consider that, okay, the future is growing within US. I'm not saying other places are not like that. There are other countries or other locations where even more sophistication is taking place. But average number of connected devices. The IoT market value will be over 500 billion in 2021. Think about all those industries which we talked about. So this is continuously growing. And by 2022, Google Home will have the largest IoT devices market share in the world. Okay, 48%. You can see this happening. Google is not just what you call the search. You're talking about this happening. Give me a second, please. Hello. ഇവിടെ എത്തിയിട്ടുണ്ടോ? അതെ 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 അതെ. Am I audible? Hello? Okay. Sorry about that. Some interruptions in between. So the use of, largest IoT device market share at 48%. The use of low power networking systems and satellite will grow by 20% in 21. This is something again I would like to put some stress on. That is the low power systems we will be discussing, but satellites, the use of satellites for the average citizen requirements is going to rise because of this IoT related stuff itself. We are talking about now few LoRaWAN enabled satellites also coming up. Even one of the college here itself, while they're planning for their satellite venture, the small satellite ones, they were considering LoRaWAN devices to be plugged into that. Even local colleges here. So there are a lot of other, even number of ISRO is planning to have some small satellites with these type of capabilities. The capabilities, why do we require that is because there are areas where even there will be no cellular connectivity, that is okay. But even without that, inside forest, inside areas where you don't have any type of connectivity, satellites can help you have these IoT devices working. So these type of low power networking systems, imagine the inside a forest getting monitored with battery operated devices which connect to satellite. They are not going to transmit signals continuously. They are only going to transmit signals probably once in a day or once in a week, but through satellites, so that you can get clear information about the environment, the environmental changes, or fire or anything, any temperature rise. A lot of things can happen, and this is going to increased by 20% in 2021. By 2025, the IoT data volume will be 79.4 zettabytes. This is crucial. This is critical. 80 zettabytes. I don't even know about the number of zeros on that or on that zettabytes, but we can understand that because you're talking about 80 billion devices, and obviously any device which you're talking about, you will have amount of data flowing inside, outside. But please remember, these data which you're talking about are not huge data like your voice data and other video data alone. You're talking about small amounts of data coming from billions of devices. Of course, you have your the other data also available, the audio and video, but IoT devices are going to give much more because of the large number of devices, and even though the amount of data being transmitted is low. So, വരുന്നുണ്ടേ അവിടെ വന്ന് എടുക്കുന്നുണ്ട്. Now, 1 second. So, what is an IoT ecosystem? This ecosystem generally consists of device hardware, device software, and the communications involved, and the platform. But generally, like these are the generic terms of that IoT ecosystem. But when you come to a little bit more clarity level, you're talking about sensor, you're talking about computing at the edge that is associated with the sensors, the communication, which takes the data to the another set of computing, which is the cloud-based computing, and based on the information gathered and the process done, you may have to take some decisions on or some action which requires actuation or actuators. So this is the complete life cycle of the IoT ecosystem, where sensor collects data, it passes the data to the computing device at the edge. Along with the sensor, you may have multiple types of computing. Something like your simple Raspberry Pi or Arduino board or whatever you talk about may have or may not have what you call learning capabilities at the edge. Some edges may not require that learning completely, but it may require some computing. For example, sensor gives you temperature data, so there is some erroneous data coming in. It should be possible for you to correct that at that level itself instead of taking it all across the cloud and doing the correction. So some amount of computing may be there. Analytics may not be much there. Then it goes to the communication. From the computing device, it needs to communicate to the heavy processing agencies or the cloud. So that communication involves wired, wireless, all those possibilities there. And then taking it to heavy processing, where heavy processing means you're getting data from thousands of such computing edges, and you're taking decisions based on that. Some of the decisions may lead to some actions, and these actions may involve some actuators. So this is the IoT general, ecosystem. Now, if you look into this, there is nothing new. We have been using all these in different forms. We had sensors, but those sensors were just to collect data. When you could view that data, collect that data, write down the data, enter it into a spreadsheet or something like that, or a computing program, do that, and then come back to solutions and then apply it. So all this hardware, all this software, the communication platforms, and some type of this were existing. So this is where we need to understand that IoT is nothing new. It is actually a consolidation of all the evolution which happened so far in computing and consolidating that into effective use for solving our problems. So we have made out certain platforms for that, and based on that platforms, we are working forward. So when you talk about computing, we know that like there will be simple single board computers and other things which is possible at the edge where we can make use of that. But on the communication side, it is either wired or wireless. And some of the main categories of IoT wireless technology, one is the LPWAN, which we will be discussing a little bit more. This is LPWAN is for providing long-range communications on small, cheap batteries that last for years. And they are expected to support large-scale IoT networks over larger sites, large area. Basically, the name itself indicates that low-power, wide area network. Once we have got cellular, that is a 3G, 4G, 5G, and plus, and things like that. These are basically phone networks, usually made for phone calls and video streaming and things like that. They can be used to transfer data. And before this LPWAN days, people were mostly depending upon these type of cellular networks itself. But the problem is that they are expensive to run and are very power intensive. Another thing is cellular networks are continuously on. You are not expected to switch it off and things like that. But our data requirement as we move forward, we'll understand that we don't require that much of things. But the earlier days of IoT, you are talking, even now, some of the IoT devices, even I have seen water meters working on 3G, but the battery life is less. They are employing methods to overcome that, but still the life is different when you use cellular, because cellular is expected to do that continuous type of streaming. There is the audio calls, phone calls, and video streaming as such. So, but still, that is a category of IoT wireless technology. Zigbee and other mesh protocols. If we look into LPWAN and things like that, there are star type of things, but Zigbee and other mesh protocols are also used, which are short range wireless and low power standard also. Mostly higher data rates, but they are generally not power efficient. Now, why power efficiency is required? Because some of these or most of these devices may have to be operated on battery. And until and unless our battery tech is improved to that extent, power efficiency is a major criteria in IoT devices. So that is one of the disadvantages which you could see. And Bluetooth and BLE, we know that most of our phones have got BLE or Bluetooth. They are short-term communication tech, which enables data exchange across multiple nodes. That is one thing. A low power version is available, but there is short range. Generally short range for the type of devices which are done. But we are now seeing a combination of the short range and long range devices, where BLE can be used at the edge level, and then at the concentrator level, we can use long-range devices. For example, there can be multiple nodes which are BLE enabled, which communicates to a concentrator, which is LoRa, and LoRa transmits it across kilometers to its gateways or base stations, and thereby taking it off. Wi-Fi, it is not so common in the IoT space, but we are making use of that for the scalability, coverage, and we are not using much of that because of the scalability, coverage, and power use. You know that Wi-Fi is heavy powered, but still that is one technology. And RFID, radio frequency identification, we use a little bit of that in basically in logistics and retail. Because some of the data to be collected can be easily done with RFID. As I mentioned earlier, these technologies work with the long-range ones, depending upon the typical requirements. So this is, I hope you are able to see this, right? Can you confirm? Yeah, okay, thank you. So this gives some information about the wireless technologies. On one side, what is the range? The other side, the bandwidth, the data sizes which you can actually transmit across. So you have different types of technologies. The notable ones are the Wi-Fi ones. At one point, you have got the 5G, 4G, 3G, 2G, etc. on that. Zigbee, which we discussed. And you have got VSATs on one side. And LP-WAN is put at a very optimal thing. In the sense that it is low bandwidth and low power as well. And if you look into IoT requirements, typically IoT requirements, we are not expecting audio transmission and things like that. IoT talks about very specific data collected like temperature, humidity, pressure, or level or things like that, which are just very small values as such collected. And they have to be transmitted across huge distance. Okay, that means our IoT characteristic is that we have small pieces of data at larger intervals to be transmitted across larger distance. So this typical criteria is being mostly met with LP-WAN, because our devices cannot be completely powered from at source from the power lines or anything. So we may have to work on battery. That actually talks about lower power utilization, and then based on that, like we have to, but at the same time, our transmission distance is large, and our data is small. Frequency of data is small. So this is where you qualify. And LP-WAN happens to be one of the best potential ones. Even though all other technologies can be made use of. All things which you see in this picture, we can make use of that. But the most optimized ones, which we consider in terms of the energy, in terms of the bandwidth, in terms of the range or the distance, LP-WAN happens to be the one. So what are low power wide area networks? So we now switch to that portion where we talk about LP-WAN. A class of radio technologies that are used for long distance wireless communication, whereas other wireless technologies like Wi-Fi and Bluetooth transfer big data packets over short distance. LP-WANs are used to send much less information over bigger footprint. Characteristic difference. Okay. Wi-Fi and other Bluetooth and other big data packets, because you're talking about audio, video, and things like that. But here, LP-WANs are used for send much less information over bigger footprints. Designed and deployed to a variety of ways depending on the target application. Now, target application is that the type of requirements which we mentioned. Look around the Sustainable Development Goals or the smart factories, all the things. We require technologies which match to that environment. So these are designed and deployed according to that. But general criteria is that it is less information over large footprint. Two broad categories, cellular and non-cellular. Of course, we have cellular LP-WANs like the NB-IoT and things like that. And you have the non-cellular. Non-cellular means you can have even private networks. And that is how in colleges like LBS we have put private LP-WAN, LoRa in a box and things like that. Private LP-WAN has been established so that you can have a 5-kilometer range around the college or the institution where you can have multiple sensors working, and you don't even have to connect to internet. Your local net can take care of the entire thing. So that is what, even when you call internet, it doesn't mean that it has to be connected completely to the global net. It can be local net also. Cellular LP-WANs, which include LTM and NB-IoT, use licensed frequencies. This is one difference. Those you now heard about the term licensed frequency bidding and things like happening. But non-cellular LPWANs, such as Sigfox and LoRa, are unlicensed ISM radio bands. So LPWANs are expected to work within the white bands or the unlicensed radio bands, which makes use of that. And it has got certain limitations based on that. So this is how what we call as low power wide area networks. So basically the things which we mentioned are considered to be LPWAN limitations. One is it transmits much less data than other radio technologies. LPWAN data rates are something like 100 bits per second or something like that to tens of kilobytes. Something like 100 kilobytes itself, kilobits per second is itself huge for LoRaWAN. I mean, not LoRaWAN, LPWAN technologies. So this could be considered as a limitation until and unless you match it with the IoT requirements. The IoT requirements are perfectly matching with these type of data ranges. But why I put this LPWAN limitations here is because you are not expected to handle large amount of data transmission on LPWAN. So you cannot expect a voice over LPWAN to be effective because you have got only this. There are cases where people are working on that, but it may not be effective for continuous audio ranges and things. Being delivered through unlicensed frequency bands, there is a higher potential for interference and errors during data transfers. This probably all of us are aware about that. Okay, you are not licensed frequency bands, so there will be a lot of other devices which may be working in the unlicensed, and there is a potential interference and errors. But technologies are taking care of that by making sure that acknowledgements are made and things like that. But there are interferences. Yeah, we should be careful about that limit. LPWAN coverage is relatively underdeveloped compared to alternative solutions. This is a comparison between cellular networks and other things. So you call cellular network is available everywhere right now. But LPWANs, usually they don't. Like in Kerala also, like where can you see LPWAN? LoRaWAN networks are available from Tata Consultancy, and Sendra Networks in India. Those are the two companies which are giving out LoRaWAN networks. In Trivandrum itself, if I talk about that, I see that Sendra's LPWAN or LoRaWAN is available only in the central part of the city. Even when we inquired about possibility of other cities, they are just coming out. Depending upon demand, they just come. They can come out very fast, but it is relatively underdeveloped. Only when you have requirements. For example, in Katakada area, which I mentioned, it is a few 15-16 kilometers from my office. We have established a LoRaWAN gateway on top of one of the rock formations there, Shastambara. And with that, we are able to cover something like 5 to 6 or 5 to 7 kilometers around that rocky structure. And you can say that with 2 or 3 such installations, we can have the entire Katakad area covered with that. But we put that LPWAN or LoRaWAN gateway there only when we had a requirement for implementing rain gauges within that area. See, that is how it comes up. But you have cellular networks everywhere. Why? Because cellular networks have got a different business line. They're talking about all the data and voice calls and things like that. So they have a different business model with which their availability is much more. So LPWAN coverage is relatively underdeveloped. So these are the limitations which we talk about LPWAN. But strictly speaking, these are not limitations for IoT. These are opportunities for IoT because the type of data which we want to transmit is less than 1 kbps. Not even 1 kbps, because at a times only, like you don't expect a 100% monitoring of temperature, something like every second or things like that. It varies. You may, in case of weather conditions, you may require only at least once in an hour. That we at our automatic weather stations, which I will show you at some point of time, we monitor at least once in 15 minutes. That is because we are doing some research work on that. That's because we want to have large amount of data coming out of that. So that is why we are using that. Otherwise, once in an hour or once in 3 hours. And what amount of data? Just a few amounts of data. Not even 1 kbps, even less than that. License frequency, yes. License frequency or unlicensed frequency which we work, that gives us an opportunity to implement such solutions without much of problems. The moment you talk about using licensed frequency, you have all type of administrative other requirements to be complied with. Here it is unlicensed, you can easily deploy. That is how, like, we could deploy a LoRaWAN in any part of Kerala or any part of the region as we move. Underdeveloped, yes. So that again is an opportunity. You can have your private LPWANs at any point of time. So talking about LPWAN history, it came around 1980s when Honeywell, the predecessor of Honeywell, which is called Adenco, they came out with some wireless standard for home security, because basically they were working on data network to monitor alarm panels, not even CCTVs or anything before that. Motorola also launched a low-speed wide area network, IRDIS, for certain sales automation and transaction tracking process. These were happening in 1980s. 1990s saw the coming up of 2G, on a cellular carrier, data alongside voice. Even now we make use of that to a good extent. But the demand skyrocketed because people are talking about all the more device requirements. But more requirements like audio and video and everything getting transmitted. So it went into the evolution of 3G, 4G, 5G and things like that. 90s was the time. So we make use of the 2G networks even now for some of the LPWAN type of requirements. In 2009, the French company Sigfox built the first modern LPWAN. So 2009, and I'm talking about 2021 now. Which could integrate applications in real time more effectively than past forms of video technology. Sigfox LoRa LPWAN is proprietary, and we have got a lot of countries in Europe, basically, and other countries working on Sigfox. Proprietary type of technology. We'll have a little bit more detail about Sigfox later on. Then in 2012, Semtech launched the LoRa protocol, which operates in various unlicensed bands. Unlicensed bands, there is a typical scenario. Unlicensed bands varies across countries. That is why you have EU license at one frequency. India operates at certain other frequency. US operates at 433 or something like that. So unlicensing depends upon the country. So normally you don't have unlicensing across the globe happening, depending upon various conditions. And again, within that, the number of channels which you can use depends upon certain limitations within that unlicensed spectrum. With LoRa, developers could deploy their own wide area networks rather than use existing infrastructure. public LoRaWAN scheme. Now, LoRa and LoRaWAN has got a slight thing, which again I will address in the next slide. But 2012 is the time when Semtech came with LoRa, and Semtech still holds the what do you call patent rights and everything for LoRa chipset. So they produce the chipset, basic chipset, but LoRaWAN is actually a layer above that, where we talk about an open standard. So this is what the history, and then there are other LPWAN technologies which have come up, which still not a global standard or anything like that, but there are technologies which are coming up, which again I will address later on. So Sigfox is a non-cellular LPWAN. Sigfox uses ultra narrowband modulation. It uses something like very low, very small data loads, something like 12 bytes of data. They have got being proprietary, and they promote things under very license type of thing. What do you call proprietary type of thing? They have got base stations all across country, probably in the US, most major US cities, and some of the European cities as well. And in India also, they are promoting like the ones in Bangalore and all. I heard about Sigfox implementation being considered. They have got base stations which connect directly to the cloud through Sigfox towers without needing gateways. So the technology is again the same thing. The devices connect to the base stations, and base stations connect to the cloud, but very, very low bandwidth type of thing. This is basically, Sigfox is basically valuable for communication through open air and noisy environments. This is something which you need to consider. Some noisy environments, they are very effective because of their very low data rate. Best suited for simple sensor devices that only need to communicate in small number of messages per day, such as threshold alerts, security alarms, emergency event monitoring. I've come across water meters which works on Sigfox technology. Even in India, even in Kerala, some company, even one company which has been incubated with us have used the Sigfox for that, because they are trying to send data only once in a day. Think about that, once in a day. The consumption value, once in a day, they will send it. Because their requirement is only that. But there may be cases where you want to have consumption data every 10 minutes or every minute like that. Probably then the technology cannot be completely used. And of course, can be used, but the battery drainage will be huge. So you may require battery replacement every now and then. So that is so the basic criteria here is, or the basic feature here is ultra narrow band modulation. Is something which is being used. Hello. ഞാനൊരു സെഷൻ എടുത്തുകൊണ്ടിരിക്കുകയായിരുന്നു ഒരു FDPയുടെ. അത് കഴിഞ്ഞിട്ട് ഞാൻ വിളിച്ചാൽ മതിയോ? മറ്റേ നമ്മുടെ LBSന്റെ മറ്റേ നമ്മുടെ LoRaWANന്റെ ഞാൻ വിളിക്കാം. Sorry about that. Okay. The non-cellular LPWAN or the LoRaWAN long range uses chip spread spectrum modulation to transfer digital information over long distances. So this is something like for general people, I say that okay, it is something like the bird chipping. That means these devices, they just chip the data, and they don't know which device is going to capture that. But gateway, when it captures, it has got permissions to acknowledge. So So it's just like the bird chirping itself on its own. Birds generally chirp this information, and some other bird captures it, responds, and goes on. That's for a layman, not for technology. But basically, that is the implementation. So here, the LoRa does that, does the chirping, chip spread spectrum. On the spectrum, just makes a chirp of a very small data, and based on that, digital information can travel over longer distance. LoRaWAN sits on top of LoRa. LoRa, as I mentioned, is a percentage passenger thing. LoRaWAN was formulated to sits on top of LoRa and is an openly available media access control layer specification. So anything coming over LoRa, how to make use of that access. So that is where LoRaWAN has been established. The scheme is resistant to multipath fading and can transfer bigger data loads than sigfox. Bigger data loads than sigfox, that's all. It doesn't mean that you have a large amount of data. Its modulation scheme helps it to be have more bandwidth compared to the ultra narrow band technology using sigfox. That means it can cater to larger number of devices transmitting at the same time. The modulation scheme is such a way that, like, you can in a gateway, under a gateway, you can have thousands of devices actually, because it all transmits data in the chirping mode or the chip model, and gateway captures that and transmits the data, or the packet forwarding is basically done on the gateway side, and that means you can have larger number. Base stations, gateways, that's a mistake here. It is gateways. Personal or public can be implemented. There can be public gateways. For example, the gateways implemented at LBS and other things are personal gateways, in the sense that only those areas. And we have recently converted that to public gateways. But of course, with a restricted control, because people can transmit, but they cannot use the applications for passing through that gateway. They can use only after authentication. So you can have personal or public gateways established to connect the devices to the internet. So gateways, what they do is, we can again see some amount of LoRaWAN details as we move on. They're doing only packet forwarding, taking the packets coming in the LoRa side, taking it to internet to specified servers where it gets processed. So that is LoRaWAN. So there are other non-cellular LP WANs. Weightless is one. With an open protocol that is designed to function within a variety of unlicensed WANs. Again, that uses unlicensed WANs. There is one company working behind that. They came out with weightless NPW. I think weightless W or P, which is being promoted now. They are renamed weightless P or W. I don't remember that correctly. As weightless itself, they came out with different LPWAN standards for that. You can look into the detail from that link, ubic.com. They got a lot of implementations coming up, but probably not as prominent as LoRaWAN and sigfox. Ingenu RPMA, random phase multiple access. Again, a company promoted one. You can look into that at ingenu.com/technology. But the advantage is that you can have 100,000 nodes per sector with a few access points. But compared to the other one, it works on 2.4 gigahertz ISM band. Even LoRaWAN now talking about gigahertz ISM band uses that, but it's not very popular. We are just starting using that. So we've mostly LoRaWAN used the sub gigahertz band. But here, this one RPMA uses the 2.4 gigahertz band, and so you're talking. It can actually cater to larger number of nodes. They have got some public networking, publicly available machine network, which provides service to more than 30 cities in the US, and specifically on that. But just want to tell you that LPWAN technologies are emerging. You can expect more LPWAN technologies coming. Of course, on the other side, on the cellular side, we have got 4G, 5G, and things like that coming. So basically, NB-IoT and things also. Now, I will touch upon LoRaWAN. Basically, you have got one more session on LoRaWAN coming up later today, not tomorrow, where you will be able to hear more of such information. But I will touch upon that. Why? Because I consider LoRaWAN as one of the LPWAN's use cases. So LoRa modulation scheme, it is basically a star of stars topology. It's not mesh type of, it's star of stars. And it is a gateway, it has got a gateway which is a packet forwarder I mentioned. Nodes and the backend services are the basic features, components of LoRaWAN. So this is typically, just want to check whether you are able to see this. Are you able to see? Are you able to see the slide?
Yes,
Can
sir.
anyone confirm whether? Okay, right. Thank
Yes,
you.
we can.
Thank you. So here, this is a typical diagram which I took about one of the LoRaWAN networks, which is the Things network. Things network is one of the largest public LoRaWAN networks. Even we operate 2 gateways on Things network. They have come out with open standards and open stack and so on. So here you see that on the left side you have got the different types of nodes. They communicate to back and forth with the concentrator or the gateways. And the gateways may have the backholes to the internet connection. The backholes to internet connection. So please remember that the gateway to nodes are about kilometers. We have some of the nodes working at something like 8-10 kilometers away from one of our gateways, smoothly working, battery operated nodes working from one of the gateways. And the largest distance checked with a gateway, LoRaWAN gateway, is somewhere around 600 kilometers. That also has been checked, and every time like we see new records being built. So that is also possible, but probably line of sight and so many other factors. This gateway, 600 plus gateway, was actually the node working, the gateway working on top of a balloon and things like that. So probably your satellites also can talk about that. So the left side network, this is actually kilometers of distance. Then you have on the right side, you have the 3G, 4G backhaul or Ethernet backhaul, which you can connect to the internet. And why internet? Because your other applications like the network server, because please remember, and you look into the diagram also, some of the nodes are even communicating to multiple gateways. It is possible. That is what I said, that chirping technology is relevant here. If you have multiple gateways around your node, the node is just transmitting that. It doesn't care about which gateway is handling it. So any gateway around that area and takes that, and they forward that packet where? To the network server. So network server will end up getting multiple packets forwarded from the same node. So they need to have a resolution and then give out only one, because at the same point of time, 2 packets may go from one node to multiple gateways, and this gateways just forwards that. They don't even check out what is happening, what is inside or anything like that. So that amounts for the security on that side. So then here the network server takes care of all the network related ones. So basically from the gateway to the right side is a TCP/IP normal network you're talking about, because it is just 3G, 4G or Ethernet backhaul. For example, in one of our gateways in Shastampara, we have put a 4G SIM inside the gateway itself. So it can transmit over that. In the LBS college, LoRaWAN gateway, it is an Ethernet connection. So it connects to the network server. It connects to the network server in our premises, in IC4's premises, because it transmits over the internet and comes to our network server. And network server, from that network server, it will be ready, like it will give all the application server can take out the essential data to be processed. Application servers can handle that. So that is how finally the data transmitted from the node reaches the application server. And the application server, you have the encrypting, decrypting, everything possible. Everything has standards there, and the data transmits encrypted all across, and you can decrypt it according to the application keys, and the data can be given out or stored or processed. And again, based on the information, signals can travel back from the services, application server to the network server to the gateway to the node or the actuator. So you have dual communication possible. So this is actually the general characteristics of most of the LPWAN technology. Base station, but LoRaWAN has got a different model, that is the chirping station. And other LP, you can think about even evolving another LPWAN technology somewhat based on these type of standards. Okay, going a little bit down, you will learn more about this during your LoRaWAN session. But just to say, you have got the different players coming there. Just understand on that left side, you have got Semtech, which has come out with the basic LoRa technology. So that is the physical layer, the LoRa physical layer, LoRa modulation, and the regional ISM bands are being used. I mentioned that EU 868, EU 433, US 915, Australia and other things 430, I think, and India we have got 865. That is the unlicensed spectrum which is available, and we make use of that. So above that, you have got the MAC options, like any networking you have got that. So here you have got class A, class B, class C, something like that, which is actually class A and class B are baseline. You will come to learn more about that in the LoRaWAN class, where class C is actually continuous. It just opens. Whereas class A, you have got, you transmit, you receive, and you have got a receive window open for few minutes or few seconds, and then it again goes for reception, like that. For class B, you have predefined receive windows so that your nodes can transmit on that predefined ones. Whereas class C, which is more power consumption, like, okay, you are remaining, the receive window is open throughout. And so that is being used for certain type of nodes where you have class C operations. Because messages go back to those nodes. Some of the actuators work in the class C type of, what do you call it, MAC options. Then that is the LoRa MAC, and above which you have the applications. So here comes LoRa Alliance. On the right side, you can see which we are sitting. The LoRaWAN is sitting on top of the LoRa, which Semtech promotes, and then you have all the media access. That means essential data access promoted through the LoRaWAN. And the LoRaWAN globally, we have got a LoRa Alliance, and actually, ICBOS is also an institutional member of LoRaWAN. LoRa Alliance, you have got every company working in LoRaWAN part of that, and it's a very steadily increasing number of members. Cisco, everyone. You're talking about LoRa being implemented. You're a member of LoRa Alliance. TCS is one, Centra is not. They are all industrial members. We at IC4 are institutional members, and we promote. That is why we are promoting these type of capacity building as well. Okay. So, going to the next slide. And why LoRaWAN? At least by this time, it is completely clear. It needs only low power, very low power for transmission because of the chipping technology, chipping modulation which we are making use of. It has got long range, it has got security, it has got network scalability, and it is possible for device updates. That is firmware over the air update, FOTA, and other things are also possible in LoRaWAN. That is why, like, if you go back to this, you can see that LoRa Alliance has got all those things built up for the media management, and so you can have device updates also possible. So these features, if you look into it, these are the specific requirements for IoT. IoT in the sense that you need to have battery operated sensor nodes, battery operated actuators in some cases, sometimes powered, but less we learn to have lower power utilization for computation, for transmission. But at the same time, you may require long ranges. You cannot put base stations every 100 meters. That's not expected. You can operate at something like 405 base stations, gateways for a larger area like Trivandrum or anything like that. So it should be possible. Security, and as I mentioned, there you have got encryption all around, so that security is taken care of as per the available standard. Security is a questionable affair when you talk about, are you 100% foolproof? Whatever your technology you're talking about, the encryption, decryption, there are loopholes in the security because it's humanly built, and there are other solutions. But of course, by the standards, it is secure. Network scalability is very easy. For example, you have a base station, a gateway, deploy 405 gateways, and the scalability is increased because of the duty cycle and other things which you can promote and things like that. It is easily scalable, and device updates and other things. So all these things promote are typically good for IoT implementation. So this is about the comparison of the LoRaWAN and NB-IoT. Now here I want to stress, now more of this probably you will hear during the LoRaWAN or the spectrum classes, spectrum-based classes which you are going to hear very soon. So here you're talking about, the point I want to tell you is that please don't consider LoRaWAN as a competing technology to some other technology. In LoRa Alliance also, we never talk about such things. This is a technology which can go hand in hand with other technologies. It is not like people sometimes ask, like, oh, come on, like 5G is coming, what is your LoRaWAN going to do? 5G has got a certain type of requirements, LoRaWAN has got certain other type of requirements. It is hand in hand working together, and because if you see that LoRaWAN gateway on the other side, we are using 4G sometimes or other technology. So that's okay. But on the LPWAN side, of course, there may be advantages and disadvantages. As I mentioned earlier, LoRaWAN, it can be public or private. But NB-IoT, very rarely it can be a private network. So here, but other than that, these are competing in the sense that healthy type of competing. One has got energy at lower level, other has got lighter more energy. Because obviously, NB-IoT you're talking about in the cellular side. So that type of differences will be there. And there are larger companies, larger associations working behind both these technologies, LoRaWAN and NB-IoT. NB-IoT is promoted by cellular, so large companies work behind that. LoRaWAN is again promoted by a number of big tech companies and things like that. So there are a lot of research happening, lot of standards happening, lot of optimizations happening. You can expect more breaking results coming up in the future days. So it is just a collaborative effort. All you need to understand is which LPWAN technology is easily available to implement your solution. Today, I will say LoRaWAN is the easiest one. You can get a private gateway for something like 6,000, 7,000 rupees. A small gateway, which can work for 1 or 2 kilometers around your house, around your housing colony or things like that. And you can start working. You can work on the battery powered node straight away. Even in people are working on disaster management cases where people can hit on a button and immediately it is notified and things like that. All this because that very low amount of data is being transmitted. So you can have battery operated nodes. Okay, how to LoRaWAN? As I mentioned earlier, LoRa enabled node, you have to have it. IC4 itself promotes certain number of nodes. We have designed nodes, we have come out with nodes. Many nodes are available. 2 years back, we found it extremely difficult to have nodes, and that is why we went on to add nodes. Build nodes, and we in some of the nodes provided with LBS and we have manufactured ourselves. Of course, manufactured at some other places, but our designs and things like that. Availability of gateway is something which you have to come across. So you can have public or private gateways. So public gateways, you have backend service subscriptions and other things. So private gateways, you have open source solutions completely available. Even big companies like Things Network, they have got OpenStack, which you can implement easily on one of your machines and you can start working. Or you can make use of the public services, backend services, like even Centra and the TCS, and they come out with a backend services subscription model, where they say that 5 to 6 nodes you can use it for free, and thereafter you get charged. Or this much amount of data you get free, thereafter you get charged. So subscription models are available. Otherwise, you use a private gateway. So it is easy for anyone to actually get into IoT solution building with LoRaWAN. And the dashboarding, device management, everything you have got open source software available. That is why ISOPOS is promoting that. Only component in LoRaWAN which is proprietary is the LoRa chip. That we say hands-on. That is something different. But LoRaWAN onwards, everything open source is available, and if time permits, I will be able to show you some of those things. So this is a open source that I mentioned about Things Network. So Things Network, you have got nodes here on the left side. They're communicating. They got come out. Things has come out with a fantastic thing. Please understand that Things Network is a company which came out through crowdfunding. I remember the days when they started with requesting for funds and the technology, things like that. Now they have got global presence. So Things Network, and they got a DB, and then it can even go to Elastic DB, that is the Google and all other things, Amazon or other cloud networks. So you can think about the existing technologies like Node-RED and other things, both for your displays and other things, or even use other technologies like Grafana and all those things happening. So this is a typical Things Network establishment. So some of the challenges which even we are talking about are the data security and privacy. This is generally IoT related one. Connectivity, compatibility and longevity, standards, intelligent analysis and actions, big data and code, information models, governance, business models. Okay, these are generic topics. Probably I just want to put it because these are the challenges for any upcoming technology. So you talk about the LoRaWAN side, it is secure, but from the gateway onwards, it is another world. So what is to be done. All the challenges which you have in the IT world, you have it here. So the connectivity I mentioned, one way or other, you can have connectivity issues. In fact, we have been working on, and in fact, LoRaWAN, LoRa Alliance is also working on something like relay networks, where even you can relay LoRaWAN from, as I mentioned earlier, from some gateways you have to have a 4G backhaul. So you can have a relay from those things all the way up to your network server and application server through relay nodes itself. So those things we are working on, because we have our own requirements for that. One of our gateway is 15 to 16 kilometer away, and right now we are depending upon a 4G backhaul, and we are experimenting with a relay network all the way across this 15, 16 kilometers. So those are basically the challenges, and yes, and the challenges we talk about, the opportunities. Some of the this possibly is for your academic team here, where there are opportunities for working on your PhD programs, on your research programs, and things like that. These are the cases which you may consider working on. Security, IoT in manufacturing, big data analytics, and machine learning. A high amount of work is going on in this. Healthcare adoption in IoT adoption, better workforce management, emergence of smart cities, cloud vending. And these are the opportunities which again comes in. But cloud vendors are zeroing in on IoT. You can see that now AWS, Azure, everyone has come out with IoT cloud solution. So all you have to do is plug in your device, connect it to a node or connected node, the gateway, and then the entire thing can be handled in the cloud. Everything. Customer service, development to come up with IT milestones. Okay. Smart stores and things like that. Now I will come to some of the IC4 specific things. As I mentioned earlier, we are into this LoRaWAN stuff since 2016, 17 onwards. Almost 2 to 3 years we have been working on this. On IoT specifically, LoRaWAN, we have been a member of LoRa Alliance for the last 2 years. So something like 3 years we have been working on this, and so we have an open IoT lab and a LoRaWAN Center of Excellence, in the sense that we have been working on that. It is not identified globally as a Center of Excellence or anything. We work specifically on LoRaWAN as one of the portions, and then we have come out with practical implementations. It is not lab implementation. Automatic weather stations, vehicle parking monitor, air quality monitor, water quality monitor, soil moisture monitor. These are the use cases which we have practical implementations. So even we have got water level monitors. We have got water meters. Probably they are not included here. I may be able to show you later on. On the hardware side, we have developed our own ultra low power LoRa node. We have assembled the LoRaWAN gateways, and the gateway at LBS and other 14 districts are gateways which were assembled, and even some of the boards were done by us. And we are hosting TTN and ChipStack. TTN and ChipStack, please, if you remember the diagram, you came to that software stack part of it, which is the application server and network server. So TTN Things Network, the Things Network, they have come out with an open source stack, which is called the TTN Open Source Stack. It is a community version. So we are hosting that, and people can actually use it. It's a publicly hosted one. But of course, right now we regulate it in the sense that not that everyone can come and use it, but you have certain regulations. And there is an absolute free software stack called the ChipStack. We host that also. Some of our gateways are operating out of that ChipStack, some gateways out of our TTN stack. And we also are part of the global public TTN gateway. We have got 2 or 3 public gateways in the. If you go and look into the Things Network gateway map, you can see in Trivandrum we have got 2 or 3 gateways on that. We work on LoRaWAN Drawn, which is again an inspiration on that access over few kilometers. So we have mounted a LoRaWAN gateway on a drone, which we again have our own team working on drone, and this we are testing it, how we can make use of increasing the distance of our reach of our gateways. Something like every 15 minutes a drone will be going up, hovering for 5 to 10 minutes, and then it will collect the data from multiple nodes kilometers away. That is our dream. Second option is every 10-15 minutes or 1 hour or so, a drone will pass across a large extent of area. You will have nodes which will get activated in the presence of a WAN, LoRaWAN gateway, and it will transmit the data. So when the drone comes back, you will have the data collected for that 1 hour. So we are working on energy harvesting nodes also. This energy harvesting is something like we are working on as something like ambient light energy harvesting, because please consider this, we require only very little power for our nodes. So that is why we are able to use the energy harvesting. So we have a practical node working which is able to generate power from the ambient light inside rooms and transmit data that is actually the temperature, humidity, air quality once in 6 hours. So no battery, effectively saying that it is no battery. Otherwise, usually you have a battery backup and all. This is not like that. It generates data during the 5 hours or so. It generates data. Generates power, and using that power, it transmits data at the end of 6th hour. This is how we are working, and then we are working on what we call as RF harvesting, because a lot of RF is all around you. So how do we harvest on that? We started working on that. Practically, it is very tough. Why? Because even then we are trying to develop systems which require transmitting only once in 2 hours, 3 hours, or 4 hours, like that. So you can use the remaining 3 hours to harvest energy. So LoRa in a box is something where you have LoRaWAN gateway, LoRaWAN application server, and LoRaWAN network server, everything into a box. Actually, the one supplied with LBS Institute, Kasaragod, and everything is actually LoRa in a box. We demonstrated that during one of the LoRa Alliance meetings in Germany. Time running up, these are some of the implementations which we have done. This is the vehicle sensor on the right side. This is on the left side top is the meteorological station. We have the air quality sensor there. We have the water quality sensor. We have a refined model of water quality sensor. This one, the sensor is all dipped into running water. That is the type of model. This one on the right bottom is actually one of the generic nodes which we developed, and in fact, LBS has that. I think for the virtual lab which you are going to use, I think we will be using another node, the TTN node itself. Things network node, which we use to get at the first instance. So this is another gateway. The same thing. You have got multiple sensors, gas sensor and other things, light sensor and everything, all on top of that gateway. These are some of the installations which we have. It takes time to load. Okay. This is the second generation LoRaWAN development board which we have developed. which has got some amount of edge computing capability. On the right side, what you see is actually a floating type of water quality node. It just floats on water, and you can see the no sensor protruding out and the antenna protruding up from the box. So that type of model which we have checked, we have certain limitations for that. The sensor is having some problems when continuously exposed to water. So that is being worked upon. So on the left side, you have got the second generation node. We make use of the ARM-based microcontroller Murata chipset for that. The high processing speed supports 860, 8915 megahertz frequency. So this node is being used in that particular water quality node. Some picture which is heavy. Yeah, these are the nodes which are deployed in the field, just to show that it is not lab alone. On the right side, you see the gateway on top of the Shastampara, which has some good height above mean sea level. It's actually a temporary platform which we are little, but the gateway is put there. That's what I said. It is able to. When we checked, we got actually signals even from nodes which were 10 kilometers away. On the middle side, you can see a water level monitoring node. It is an ultrasonic sensor which is being used. And just below that is the energy harvesting node. And the left side is the typically Katakada, where we had deployed that, what do you call, the automatic weather station. So these are the deployments which I would like to share with you. Because before I conclude, let me show you some of the implementations. Data from the implementations. Are you able to see the screen? No, I need to shift to another window. Just give me a moment. Go for rendered screen. And let me show you. Are you able to see my screen now? Yeah, so this is actually you can go to this link anytime. This is a project which has been done for the automatic weather station at Katakada, which I discussed some time back. So here you can see the Shastampara gateway location on the map, and the node positions on the map. On this, St. Xavier's HSS Payard. The basic data which is at present there is given on touching that symbol. So you have got the data, the temperature, pressure, humidity. We have an issue there. This is something which I want to, or say later you will come across that. Our implementation using the humidity sensor when exposed to open conditions have got a problem. That is why it is showing 100%. Actually, it is not 100%. It's less than that. So rain is 14 millimeters, something like that. Let us see the data now. This is using Grafana. Grafana is a visualizing tool which you can, open source visualizing tool which you can take up. I think the slowness is because it is heavily data loaded now. So this is for the local people, local panchayat and everything. So we have put it in Malayalam itself. Excuse if there are people who are not able to understand the Malayalam part of it, but I think we have the English titles also there. The current temperature is 23.1. Humidity, forget it. This particular portion is having error. So the temperature graph is there. This is actually last 24 hours. The pressure is there, and rain, 1.68 mm rain has been, it's there, and it shows the graph when exactly that is happening. And the wind speed at that point of time, wind direction. So we have graph about, so this graph gives you the wind speed variation during 24 hours. And the right side, you can see where exactly the wind is happening most time. So these are crucial information. And see, this has got, probably you can take 2 days data and see. Yeah, there you see 2 days data. So rain is this one. This is the wind direction. Or even, let me try. I'm not sure, like you have got 7 days. Let me take 7 days. So this is formulated using the same technologies which we talked about right now. LPWAN, LoRaWAN, the nodes which you saw, our own nodes, developed nodes which work, which are connected to sensors, and then it gets transmitted to the Shastampara gateway, which is around 4 to 5 kilometers from each one of these nodes. You saw the map here. You saw the map here, right? Sorry. See, this is where the gateway is, and these are the nodes which are ready. So you see data from, and this data is actually from the chip stack which we are hosting. The entire data, 7 days data. There may be some errors, like I mentioned. There may be some errors. We are experimenting with that. Temperature, the rain, 55.72 millimeters of rain during 7 days. And we have tested this with the meteorological data. We are less than 10% error, less than 10% error regarding rain. Less than 10%. Normally it is 5% or so. Let me show you one of the water meter. This is a water meter which is put in my apartment itself. It works on LoRaWAN. And this shows the water data, consumption of water. See, here you can actually download the data also if you require. Even in most of our implementations, we have provided that download data facility as well. So here, water meter, what we have done is we have used a standard water meter. Standard in the sense that you have a magnetic type of sensor, signal coming out of that pulse water meter. And from that pulse, you have connected to a LoRaWAN node, which is battery operated. You are getting the battery voltage, battery level at that time, 3.55 voltage. So our LoRa nodes work for the 3.3 voltage, and so even if it is safe. Now so that is the data coming out depending upon your selection. And here, in this case of the, the automatic weather stations, actually these are battery operated. All these are battery operated. And it works, it has got a solar augmentation as well. Okay, so that is the condition. The actual display and everything is using Grafana, which is open source tool, and You have got the entire thing open source. We work with open source technologies, except that LoRa chip, which is proprietary. As we went through that presentation, it is part of the evolution of LPWAN, and we hope to have some other chipset technology which also comes under open source at some point of time. With that, I would like to say thank you to all. Just to put and their screens once again. You have. This is what. If you think that the internet has changed your life, think again. The Internet of Things is about to change it all over again, and that is what the passing message I would like to give to all of you. Thank you very much for the patient hearing. I hope I could conclude within the permitted time. I took 7 minutes extra. Sorry about that, to keep you waiting for the lunch or whatever it is. If you have any questions, please let me know. Or if you want to take up the questions later on, you can put that to email to me, or you can contact me, and we can take it up. Thank you very much. Okay, I think that is fine. I hope there are not much questions, because this is more of an introduction covering the total gamut of things.
Okay, then we will wind up. We want to thank Srinivasa for this good introduction about IoT and LPWAN. I hope the participants are clear with what is LPWAN and why it is called so. So thank you, sir, for that informative talk. And we also want to acknowledge APJ Abdul Kalam Technological University, who have sponsored this FDP, and we want to thank them for selecting our FDP and allowing us to conduct this faculty development program. So thank you, sir, one more time, and thanks for the entire ICFOS team. We will be joining in the afternoon at 1:30 p.m. for the next talk. It's about spectrum sensing by Gandhiraj sir, and later in the second section today we will have hands-on sessions handled by the ICFOS team. So join at 1:30 p.m. I will also share the feedback form. It's a simple feedback form, and just to collect the attendance also. So that also I will be sharing in this in the chat box. So kindly do that also. So thank you everyone for joining. I will be opening the room by 1:20 p.m. So please do join at 1:20 p.m.
Okay then. Thank you very much. Thank you very much.
Thank you so much, sir.
Have a great time. Stay safe.
Thank you, sir. Wish you the same.
Thank you, sir. It's really informative, sir. Renzi, sir.
Teacher.
Okay, ഞാൻ ഫോണിൽ വിളിക്കാം.
Okay.